Okay, so we're back with another method that you can't say, nor pronounce, nor spell. Ho-ho! Kjeldahl. Kjeldahl. What does that spell? Kjeldahl. What does that spell? Kjeldahl. That's what that is. Kjeldahl method. And because people can't say it, pronounce it, or spell it, what they do is they just shorthand this thing and they say, ooh, I'm going to do a TKN method. And the K stands for Kjeldahl. That's what that is. So the word Kjeldahl, of course, has to be coming from somewhere across history of the great and latest scientist that came up with the Kjeldahl method. Mr. Kjeldahl did the Kjeldahl method, believe it or not. Go figure. No one says this is rocket science. So the Kjeldahl method is very specific because a lot of our tests are really that we're doing in this course. It's called advanced lab methods. So what's going on is that we are introducing various pieces of glassware that you maybe not have seen before, or processes that you are going through that you don't get a chance to do in a regular type of science laboratory-based course. And this is one of those. So the Kjeldahl has made its home many, many, many years ago. And that home had a very good foundation, and that home is still standing today. And the reason that I'm saying that is because the Kjeldahl method is still used, especially in like an environmental or food and beverage company, almost on a daily basis. Kjeldahl is very important, but yet Kjeldahl is something that many people or many classes or many instructors do not introduce. And the Kjeldahl method is all about the N of TKN. And if we know the K is Kjeldahl, the N is actually going to stand for nitrogen. Now, let me write that in white. Maybe that's a little bit easier to see. Okay, so TKN. T, what does that stand for? If K is Kjeldahl and N is nitrogen, what does the T represent? And the T is going to represent the word total. So TKN means total Kjeldahl nitrogen. It's just a fancy word or words that we use to describe a process. And this process really kind of takes place no matter what type of sample type that we have with it. Whether we've got a food sample or an environmental sample, or in this case, a fertilizer sample, it's all pretty much bare minimum, bare bones. This is what you do, and this is the order of operations. So we're going to get you to go through the TKN process, and keep in mind that you probably are going to see this again, especially in our food chemistry class, where we begin to talk about how do they calculate the protein content on food items, because protein is loaded with nitrogen. And if we have an idea of the nitrogen in the food sample, then we can also have the idea of a protein amount in the food sample as well. So that's what we're doing in this lab activity. We are introducing you to the TKN that you'll see again using different type of samples the next time that you see it. And we're going to give you the basics of what you need to know about how to do this process the right way, or this lab method the right way. And we're going to change it up a little bit. And it seems like a lot of things that we do in the program are pharmaceutical type based tests. And in this one, we're trying to get away from that as well. Yet again, we're getting away from the pharma environment because we need to change it up. And for this lab, we're going to go more, I would say, environmental. And we're going to focus on a fertilizer sample. So we brought a fertilizer sample in for you. And this fertilizer sample is going to be measured and quantified. And we're going to take a look at the total nitrogen content inside of that fertilizer sample. And we'll compare it to the label amount. So we want to make sure, is that label like legit? Are they really telling us the right story? What's going on? So before I talk about the Kjeldahl method and the pieces and parts that surround that, I want to talk a little bit about fertilizer first. I know that maybe many of you know what fertilizer is. You might not have ever used it, but you know what fertilizer is, and you know what the purpose of fertilizer is. And fertilizer will come to us in many different forms. I will say that very often we are looking at micro and macronutrients. And the reason that I say this is because there are blended fertilizers that look at micronutrients, which are nutrients that probably plant needs in very small amounts or very small quantities. And you're seeing some of those on the screen here. So when we look at magnesium or zinc or calcium or chloride or sulfur or iron, not all plants, but many of them need some of these little multivitamins in a way of metals, or in not all cases are metals, some are non-metals, but they need some cations and anions in order to do their job. So nice little food, a nice little booster, and that's what some of the macronutrients are going to focus on. Macronutrients, what I like to kind of refer to that as, are the big players, the big heavy hitters. So there are actually 3 of these, and those are almost on every common fertilizer bag that you're going to see. It is N and the P and the K. So as you can imagine, the N, of course, is going to stand for nitrogen, because if I look on the periodic table, N has the atomic symbol of or for nitrogen. So they just pulled that from the periodic table, slapped it onto a bag, and that's going to stand for nitrogen, of course. And this is what the Kjeldahl is going to focus on. Not all fertilizers have nitrogen, but many of them do. Many of them are a blend of all 3 that I'm going to mention here. But you can get what we are going to classify and name as single element fertilizers, and I'll go into more detail of that in just a second. The P is going to stand for P on the periodic table, and that's going to be phosphorus. So phosphorus is another element that is blended inside of a fertilizer sample, again as a multivitamin in a way for these plants to grow and for them to flourish, and that's what this is all about. And then K is also coming from the periodic table, and K stands for potassium. So what we're looking for here in most fertilizers are 3 numbers, and those 3 numbers are in reference to the N, the P, and the K concentration. So the nitrogen, the phosphorus, and the potassium. A little more detail about fertilizers, again, before we get into the Kjeldahl. I just mentioned that there are fertilizers that just have one of these 3 major players. And if you get one out of the 3, then what we do is that we call that a straight fertilizer. So I can go to the store, or I can order fertilizer that maybe just has nitrogen in it and that's it, or just phosphorus and maybe that's it. But that's up to me as a consumer. I know kind of what my plants need, I would at least hope. And maybe I don't need all the other stuff. And because of that, a single straight fertilizer is available to consumers if they want it. However, general run-of-the-mill consumer doesn't really understand that concept, and they will go and just buy a general purpose fertilizer. And a general purpose fertilizer is often what we call or categorize as a complex fertilizer. And a complex fertilizer is, of course, things that have 2 or more of these big heavy hitters that are in them. So maybe nitrogen and phosphorus, but no potassium. Or maybe potassium and phosphorus, but maybe no nitrogen. That's just really up to the blend of the fertilizer that I need as a user. Because again, maybe I know a little bit more information than the general consumer, and I know what I'm after. And maybe all 3 are really not ideal for me. So that just really depends on what I'm growing, how I'm growing it. Is it a fruiting vegetable or plant, or is it just kind of a flowering plant? All of those talk different ways and have different needs, but a general all-purpose fertilizer, like you see in this picture, is going to have all 3 of these, maybe in different amounts, but all 3 are mostly represented. So if I look on this fertilizer bag down here at the very bottom, I'm going to see 3 digits. Very often it's on the front of the bag, toward the very bottom, or in the center. If it's not there, you'll see it on the back of the fertilizer bag. It's not a big deal, but it's going to be listed in some form or fashion. And these three numbers are coded for, again, the N, the P, and the K, and they go in that order most of the time. So the 12 and the 5 and the 7 that you're seeing in this picture has 12% nitrogen, 5% phosphorus, and 7% potassium. Again, those numbers are in that order because very often we talk about NPK values, and because it's just widely accepted to go in that order, NPK, 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 then 12, 5, and 7 match it. So NPK, the first number, and then the second number, and then the third number. That's what this is. There's also two different types of fertilizer that you might see. One is something that we would call organic, and the other one's going to be inorganic. People, ooh, I'm fancy, I want organic. All that is like manure, and it's blended up and it's put into a bag and you're shoving your hands in it. So if you are that type of person, then great, go for it. There is a need for that. There is a desire for that. A lot of people don't understand what's inside of those bags when they buy them, but that is an organic fertilizer. So very often these are recycled plant material and it's recycled animal material. So for instance, an organic fertilizer, think about in the fall when all the leaves fall from the trees and they go on the ground. If you leave those leaves there, they eventually will decompose, they'll crunch up, they'll somewhat disappear, right? But you know what they're doing is that it's like a Mother Nature's way of fertilizing the ground that sits below a tree. So a lot of these will have nutrients that they can supply to the soil, and if you go through and you rake up all of those leaves and all of that kind of decaying matter, then what you're doing is that you're stripping natural fertilizer from the ground. So you're removing that actually, because that could be a potential source for nitrogen and phosphorus and potassium and all of the other macronutrients as well. If you go and purchase a fertilizer bag that is not deemed organic, then by default it is understood to be inorganic. And what that means is that this blend has been created and mixed and blended in probably a manufacturing type of facility. So they need a nitrogen source that they can measure out and add to the mix. And then they need a phosphorus and they need a potassium source as well that they can add into the mix, and they'll blend it all up. And then they can add filler, they can add some bulking agent to it. So that way when you put your hands down into that fertilizer and you sprinkle it across your lawn or your flower beds, then you're not kind of putting your hands in full-blown chemical reagents. That's what an inorganic fertilizer is. So traditionally these are going to be salts, and these salts have to be most of the time preferably water soluble. So of course so, right? We want fertilizer to dissolve. We want fertilizer to be placed into a pitcher of water and dissolve quite easily and quickly, so that way I can take my water pitcher and pour it over the plants. Or I want my fertilizer to be scooped out of the bag, sprinkled on the flower beds directly on top, so that way when a water hose hits them or when the rain hits them, then it can help dissolve that fertilizer and push it into the soil, so that way it's going to be available for the root system that is under our ground for the plants that need it. So organic and inorganic. And as far as the inorganic goes, you're going to see no carbon containing materials. That is something that is out there. That's something that we would like to stress. But I don't really hit home on this, because no carbon containing materials, basically, in other words, these are salts that can dissolve easily in water. That's what that is mainly. But there is one exception here, and that exception is urea. Urea is an organic compound. Urea, carbon is present in the molecule. So for that reason, urea doesn't quite fit the mold, even though they can use it and get by with the word inorganic. But just kind of a little misnomer. That's all that is. But organic basically is coming from plant or animal decaying matter or material. And then inorganic are typically salts that we're measuring out in big old vats or big vins, and we're blending it up and we're making a fertilizer sample. Again, NPK is what's going to be on the label in that particular order. So nitrogen, phosphorus, and potassium. The rating, like we talked about before, the 12, 5, 7, those numbers will match that order as long as you're in the United States. And here's another example of 10, 10, 10. So a 10% potassium, a 10 or nitrogen, a 10% phosphorus, and a 10% potassium. That's what this is all about. All right. A couple of maybe tidbits of information for you. N, P, and K are chosen for a number of reasons. And those reasons you're seeing on the screen right now. A lot of people that use fertilizer keep this little kind of rhyme in their head on picking out which piece of the fertilizer is actually doing the job. So up is nitrogen, down is phosphorus, and potassium is all around. That's kind of what they look at. So the first, the second, and the third letters or the numbers, nitrogen up, so it makes the plants grow faster is what those are. Phosphorus is down. So phosphorus goes into the root system. It goes further down into the ground, and those roots are going to suck that up and make more flower blooms. So you're really anchoring the feet in. And if you've got a flowering plant, then you probably want to give them high amounts of phosphorus in order for them to bloom much prettier, healthier blooms that maybe last a little bit longer. If you want your plants to grow quickly and tall, then phosphorus is not going to do that for you. Nitrogen is going to do that for you. So the nitrogen is going to make it take off. It's going to grow quickly. And then sooner or later, when the plant grows up to the height or to the size that you need, you might switch over to a phosphorus fertilizer at that point, because at that time you want it to maybe not grow as tall, but you want it to get fuller. You want it to have all of these beautiful blooms that might happen in the summertime or in the springtime. And then potassium, they will say, is just all around. So potassium doesn't quite make it grow taller easy. It doesn't make it bloom easier, but potassium is there because it does kind of both. It just doesn't do the job as well as nitrogen or phosphorus does. So they add in a little booster, they add in a little bonus, and that's potassium, and it does control and help that general fertilizer do both jobs. Even though it does have nitrogen and phosphorus in it as well, potassium also plays a role in that. Not a big deal at all. All right, but most of the time, that's why N, P, and K are in all of these general all-purpose fertilizers. As far as the biggest fertilizer production country in the world, of course, it's like everything else, China. That's what this is. So China is the largest producer, but also China is the largest consumer of nitrogen fertilizer. So they want things to grow fast, they want things to grow big, they want things to grow tall, and nitrogen fertilizer is the way to go with that. So they are producing it, yes they are, and they are selling it across the world, but they're also consuming it too as the largest amount of any country in the world. The United States doesn't trail too far behind though. The United States is the third largest consumer of nitrogen fertilizer, and they're also the second largest producer of the fertilizer. So China is in spot one, but the United States is not too far behind at all. Next up, this graph that you're seeing here, of course, will rank China up here at the very top, and then the United States comes in number second, and then, of course, India is going to be 3. India's population's booming. Of course, they need food. Of course, they have the resources to produce these fertilizers, so they have a need for it. They have a drive for it, and they've got some available resources that they can make it as well. So those are the top leading countries in the fertilizer world, and that might be interesting to you if you like this whole environmental spin about clean air, clean water, clean soil. I mean, that is part of what this is all about. And how can we make sure that these things are growing in a healthy environment? And that does start with the soil and the nutrients that are there that's available for the plant material to use and to grow with along the course course of its lifespan. All right, so that's where I'm going to stop this video. In the next one, we're going to focus more on nitrogen as a whole, because that's really what this lab is about. Kjeldahl does not care anything about phosphorus. Kjeldahl does not care anything about potassium. That's not what Kjeldahl does. Kjeldahl is simply a nitrogen measurement technique. That is what this is all about. But many, many different things have nitrogen in them that we would want to measure and report on. And this fertilizer is just one little bitty tiny sample that we can use in a laboratory for a Kjeldahl method. So in the next video, we'll discuss nitrogen a little bit more, and then we'll get into the nitty-gritty of the Kjeldahl lab experiment. So I'll see you when you get back. Again, take a potty break if you need one. You are probably crashing out on videos right now. This might not be your only one for the day. And if so, woohoo! I'm so glad to spend it with you, and I'm so happy, and I'm ready for the next. So come back and see me. I'll be waiting patiently. Don't leave me here hanging, please.